Hello, so today we are going to do this problem called word subset. So the problem says we are given two arrays, words 1 and words 2. We have a definition of a word being universal. A word from the first array, which is words 1, is called universal if every string of the other list, which is word 2, and let's call that B, for every B in words 2, B is a subset of A. And what a subset means is that basically for each character in B, the number of occurrence is smaller or equal to the number of occurrences in A, right? So every letter in B occurs in A, including multiplicity. That's what that means. So if we take a look here, with WRR is a subset of warrior, right? Because you have one W and two R's. Right, so here we have 3 R's even. So as long as the count in B is smaller or equal for that character in A, in the word in A, A is a word in words 1, then we can say that it's a subset, right? And if for all strings in B, all of them are a subset of the string in words 1, then we can say that it's universal. Right, I know that's a little bit confusing, but let's take a look at an example. So the goal here is to return all the universal strings in words 1 according to this definition of universal, right? So let's take a look here to understand. Here it's some sort of a bad example because it's just one letter, but it will give you an idea. So if we take a look at Amazon, we have O, but we don't have E. So it's not universal, right? If we take a look at Apple, we have E, but we don't have O, so it's not universal either. Facebook, we have E and 2 O's, so at least one O is there and one E is there, so this is good, right? Okay, and then here, Google, same thing, we have E and O, so good. Leetcode, same thing, so good, so we return these 3, right? So that's the idea here. If, let's say, the words 2 has just had double O, then we'll return only Google and Facebook, right? Yeah, so that's the idea. Now, one thing to note here is that the length of word 1 and the length of words 2 is up to 10 to the power of 4. So we can't do a nested loop, right? Because then it's 2 to the power of 8. And so it's, yeah, that's not, that won't pass. So let's see how we can solve it without doing that double loop. Okay, so let's see how we can solve this. So given this example, what would be a good idea to do here? So we can definitely take every word, right, of words, and then go through after that every word in, so let's call this A, in words 2, and then check for this word if every character in B is in A, right? If it is, then we can add to the list of universals, we can add A, right? So we could do that, but this, as I said previously, is time consuming because it's the length of words 1 multiplied by the length of words 2, which is 10 to the power of 4 here. So 10 to the power of 4 by 10 to the power of 4. So that's too expensive. So what can we do here? So what we need from this statement, what we need is for A to be universal is that every count of every character in B, let's say C here, for every C in B, right? The count needs to be smaller or equal than the count of that character in A, right? Why is that the case? Because let's say we have in B from words 2 is 3 O's, has 3 O's, right? Not necessarily consecutive, but has 3 O's. What do we need? We need for A, we need A to contain at least 3 O's. It can contain even more, but if it contains only 2, then that's not, then B is not a subset. So we need it to contain at least the same number of counts or more, right? So what if we have B1 contains 3 O's, B2 contains 2 O's, and B3 contains 4 O's, right? Well, at least we need A to contain 4 O's, right? Because then B1 is a subset, if of course other characters exist, and B2 is a subset, right? So we need it at least to contain 4 O's, right? So from this we can deduct that what we need is the max for each character, right? For each character C, we need the max count of all the B's to be smaller or equal to the count in A. Count of that character in A, right? Because once the bigger number of occurrences for that character exists in A, then yeah, we know all of them exist, right? So that's the main idea that we will run with here. So what this would mean is all we need is for every character in all the B's, we need to find its maximum number of occurrence in each word in B in words 2. Once we do that, we can just check for every words A if the count of each character that exists in all of the B's is smaller or equal to that of A. I know this may be a little bit confusing, but just think about it slowly and just run with a couple of examples. So what this would mean here is, for this example, is that since E occurs at most once in all of the characters, in all of the words in words 2, and O occurs only once, all we need for each word is to contain both at least once, right? And so we can just go through this. Amazon doesn't contain E, so we reject it. Apple contains E but doesn't contain at least one occurrence of O, so we reject it. Here, Facebook, the count in A of E is equal to 1, and the count in A of O is equal to 2. And so we deduct, and the max here for count of B of E is 1, and the count B of O, the max, is 1, and so this is smaller, right? And this is smaller or equal, right? This is smaller or equal, this is smaller or equal, so we deduct that Facebook is in the list of universals, so this one is good. For Google, count of, let's see for Google, what's the, so count of E is 1 and of O is 2, so again, it's good, so this one is good, right? So that's the main idea here. If you take a look also at Leetcode, right, Leetcode, the count of E is 2, the count of O is 1, right? And so still smaller or equal, smaller than equal, so it's good. Now let's suppose we got maybe ET, words 2 was ET, and maybe just O, right? So what would happen in that case? So in that case, well, E existed in the words of B once, T once, and O once, right? So here, let's have another count of A. Right, so count of E is 1, this one is 1, and count of T is 1 as well, right? So we start with the words Amazon, right? Amazon has A twice, we don't need to worry about it. It has O once, but doesn't have E and T, so, or we can say that it's equal to 0, so it's this, for B is bigger, so it's not smaller or equal, so we reject Amazon. Apple, count of T is equal to 0, so it's smaller than the count for B, so we reject it. Facebook, T also is 0, smaller than 1, so we reject it. Google, same thing, T equal to 0, smaller than 1, we reject it. Leetcode though, T is 1, right? E is 2, and O is 1. So smaller or equal for T, equal. For E, 1 is smaller or equal to 2, so smaller, it's smaller, so it's valid. And O is equal, so smaller or equal is valid as well, and so we pick Leetcode, right? So that's the idea. All we need is the max occurrence of each character in all of the B's, and we can compare them against each O's. So that's the main idea here. That way, basically, what this would mean is that we need one pass to calculate the max count B, right? And then after that, we do one loop over each word in words 1, and just check, compare, right? Okay. Now let's write this down and make sure it passes test. Okay, so let's write down the code and make sure it passes test cases. So the first step we need is to get the max count for all the letters in all the words 2. So actually, just make this easier. Let's name this B, and let's name this A, right? Because we know ones are A's, the others are B's. So we need to return a list of universal letters. So let's initialize them, universal words. And now what we need is to get the max count for all the words in B, right? So let's go through them. And we need to have an array for the max count. Okay, and let's initialize it to a dictionary, right? Just a map. But we want it to default to int, so that basically initially the value is 0 for every character. That way we don't need to check if present to initialize the map value. And now we want to compare against the occurrences in this word in B. So we need to go through every character in B, and we want to say new count for this character. It has increased by 1, right? Because we just found it. So this is the new count for B, right? Or let's call it just count B. And now what we want is to maximize for this character, get the max of whatever we had before, and the new count in this B that we are traversing here, right? So once we get the max there, we want to go through the words. So now we have the max in this, the max occurrence for characters in each B in this max count B. So we are going to go through the A's and get the counter for the A's. So let's call it sorry, count A. And it just we could use a map, and so something like this, or we could use just counter. And here, if we could do something like in A, count A of C plus 1. So that's one way to do it, or we could just use counter of A here. Okay. And now we can check for all C in the max count B here, the items there. So for all the characters present in all of the B's, right? And so here, this would be the value. We just need the character here. We don't need the value. Or we need it actually. So count B, right? So what do we want to do? We want the count of A to be for that character to be bigger or equal than count in B of that character, right? And we want this to happen for all of them, right? But so we just say all, right, have this valid. All of them have this valid for, yeah. So we do something like this. Now, if this is the case, that means we can. So if this is valid for all of the B's, then we can add it. We can add this word A in the list of universal words. Okay, and this is actually a pin because it's a list. And then at the end, once we check it for all of the A's, we need to return universals. Okay, so that's pretty much it. So just get the max count for each character in B and check for every word if the count is smaller or equal for each character, right? Okay, so now let's run this. In terms of, let's submit actually before. Okay, so that passes test cases. Now, in terms of time complexity, we have here O of B. If we can call this O of B. And then we have here the count of B, basically. You can say the number of B's. So let's call it B like this, or Bn. And then here it's the count of An. And of course, like here we go through this at least the number of characters. Because this is only lower case English letters, we can say it's 26 times the length of A, so it's called An, right? And so overall it's this multiplied by Bn, plus actually Bn. Okay. Yeah, so 10 to the power of 4 roughly plus 10 to the power of 4, it's not too big. Now we can improve this code slightly, where we can, instead of counting for B here, we could use counter. Same way we used it here for A, for Python. So we could do counter here of B, like this. And that way we don't need this. We still need to get the max, right? And now let's check this. And this should work. Okay, so that passes. Now we can rely on something in Python counter. Basically, we don't need to loop for every character because Python, with the OR operator for count, for this counter class, you could get the max, the same thing we are doing here. So it's a union, basically, and so if B occurs 2 times in one counter, and then occurs 3 times in the other, so maybe in C1, B occurs twice, and then in C2 it occurs 3 times, then if we do C1 or C2, we will get B equal to 3. So it gets the max every time. If you want the min, you can use AND operator, right? So here we can just use the OR operator. So that way max count is just going to be OR for the count of B. And that way it will get the max for each character, right? And so we actually can just use this like this, and reduce this to that. And if we run this and submit, okay, so it seems like there is, yep, so this shouldn't be a collection now, since now we are using OR for a counter. We want it to be initialized to an empty counter, right? Because every time we do OR, it will get the max. So the max of 0, which whatever is in the first B word, should give us the count of what's in B. So if we run this and submit, okay, so that passes test cases. Yeah, so that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.